Topic of our chapter is preparations of carboxylic acid. How we can prepare the carboxylic acids? They are prepared by the several oxidation reaction using mild or strong oxidizing agents. So if it is prepared from aldehyde, so the preparation is from aldehyde. Aldehyde is nothing but RCHO. So CHO, that is the aldehyde containing compound, is oxidized in presence of first reagent is KMnO4. It is a strong oxidizing agent, that is potassium permanganate. It results in a acid, formation of acid. Example is I gave acetaldehyde. In presence of potassium permanganate solution, it results in acetic acid. So oxidation of aldehydes, that is oxidation of aldehydes in presence of strong oxidizing agents, it results in corresponding acids. And next one, acid is prepared from alcohols, that is alcohol means a compounds with OH group or OH. First ROH, that is alcoholic compound, is converted into aldehyde, that is in presence of mild oxidizing agents, not in the presence of strong oxidizing agents, only in presence of mild oxidizing agents. It will converted into corresponding aldehydes. Then the aldehydes are again converted or react with strong oxidizing agents. It results in corresponding acids. So I gave the example of ethanol, that is CH3CH2OH in presence of manganese dioxide. MnO2 is nothing but manganese dioxide, and or otherwise a Tollens reagent. So either one of the reagent we can use for the oxidation of ethanol. So it results in a acetaldehyde. Again it reacts with potassium permanganate, which is a strong oxidizing agent, or either with the potassium dichromate, that is K2Cr2O7. Either one of the reagent we can use. It results in a product called as acetic acid, that is CH3COOH. Third method of preparation is from nitriles. Nitriles are nothing but the cyano compounds. Nitriles are nothing but the cyano compounds, that is C triple bond N will be there, that is called as cyano group or nitrile group. C triple bond N is there, that is called as cyano or nitrile group, which is attached with alkyl or aryl, called as a nitrile compounds, which is called as nitrile compounds. It is through a hydrolysis method using a acids. Through a hydrolysis method using a corresponding acids, it results in a acid, that is C triple bond N. In presence of acid and a little amount of heat, it converted into RCOOH. I gave the example is called as propane nitrile, that is called as propane nitrile. We consider the functional group carbon also included in the naming. Okay, so CH3 1 2 3, so it called as propane. C triple bond N is called as nitrile, so it is called as propane nitrile. It's called as propane nitrile. In presence of acid and heat, in presence of acid and heat, converted into corresponding propanoic acid. Then the fourth method is carbonation of Grignard reagents. Carbonation means addition of CO2 group. Addition of CO2 group. So general reaction is organomagnesium reagent, that is benzene is connected with the MgX, that is Grignard reagent. In presence of a carbon dioxide, corresponding carbon dioxide, it produces a magnesium carboxylates, that is COO is insert between the R and Mg, that is R and Mg. So R COO, the insertion of carbon dioxide, and MgX, again in presence of acid, wherever H3O plus is there, it considered as a acid. It results in a, that is RCOO single bond MgX is converted into RCOOH. I gave the example of alkyl example. Here I took alkyl halide, and in presence of magnesium and ether, it produced a corresponding Grignard reagent, that is insertion of magnesium in between C and Cl. It produces a C and Cl in between, Mg is there. It's called a Grignard reagent. And next it reacts with CO2. In presence of acid, it produces CH3, COOH. Next method, that is fifth method, is oxidation of alkenes, which results in a corresponding acids. So I gave example itself through a ozonolysis method, that is CH3 single bond CH2 single bond CH, a double bond CH2. If whether the double bond is present, then the compound is called as alkene. In presence of O3, O3 is the reagent which is used for ozonolysis method, or in presence of strong oxidizing agents like KMNO4 or K2Cr2O7, which is nothing but potassium dichromate. Corresponding acids are prepared, that is a double bond will get break up. The double bond will get broke up, and either parts are considered into or converted into acids. Either parts will be converted into acids. I gave the ozonolysis method for alkene. Here I took the starting material which have a double bond CH, that is above one itself I gave CH, double bond CH2. It undergoes a ozonolysis, that is O3 reagent. Along with the O3 reagent, a double bond, one of the pi bond, that is double bond means one is sigma bond, another one is pi bond. That pi bond is attached with oxygen bridge. That oxygen bridge will get broke up, and either part will converted into OHs. Then the next method is hydrolysis of acyl chlorides. Hydrolysis means wherever the term hydrolysis we are using, that is addition of acid or in presence of acid. The hydrolysis means in presence of acid. So I took the starting material acyl chloride, that is acid chloride. The other name for acyl chloride is acid chloride, or C double bond OCl is the general formula for acyl chlorides. I took that, and in presence of acid it converted into RCOOH. Down I took the example of CH3COCl. In presence of water relieving Cl, it gives a RCO double bond OH, that is an econism. If you want you can write, otherwise you can simply write it as CH3COCl2 CH3COOH. CH3COCl2 CH3COOH in presence of acid with the relieving of Cl. You can write up to that.